Check the stream is started or not. Okay, those. So hello everyone. Today we are going to discuss what problem A to F in division 2. So now let's start with the problems. So the first problem is playing with the toys. So in this problem, Jeff got n toys for his birthday. Every day, if he has at least one toy with him, he plays with one specific toy for that day. Unfortunately, Jeff is very careless and will inevitably break that toy by the end of the day. When he breaks he does not play with the new toy but waits for the next day. After m days, how many toys will Jeff be left with? Okay. So in this particular problem, okay. So in this particular problem, we are given with Jeff has n number of toys and he has m days. Every day he plays with a toy and break it. So after m days, we are asking how many toys are left with the Jeff. So it is very clear that if he has m days and if number of toys, that is n, is less than m, then he will eventually have zero number of toys after the mth day. But if he has more than m toys, like is n is greater than equals to m, then the answer is the remaining amount, how much toys are left with the chef. So the amount will be n minus m. So this is the logic for this problem. As you can see, I have taken the input n and m. If n is greater than m, we can just output m minus m, and else we can output 0 for this problem. Okay, moving towards the next problem. In this problem, we are given with an array in A and length n. The array will be called good if the sum of the elements is non-negative, which means a1 plus a2 plus a3 dot 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 an is greater than or equals to 0. Find the minimum number of non-negative integers x such that if you add x to each element in the array becomes good. That is, if an array B of length n defines as bi equals to ai plus x. Okay. So in this particular problem, we are given with an array a1, a2, a3 up to an. Now we have seen that we are also given that a good array is something whose sum or is greater than 0. We have non-negative sum, which means the sum of the array is greater than or equals to 0. Now there are multiple elements which might be negative. If a array consists of all positive elements or the sum of array is positive, then we need 0 number of operations, right? But if the sum is negative, then what is the total amount that we have to add such that the array becomes positive. So we can conclude one thing, that if my array element is like this, 1 minus 100 and let's say 0. So this is my array. In this the sum is minus 99. So I need 99 more to make the array sum positive, right? So what I can do is I can either add plus 99 to this element. Then how many operation I have taken? I have taken let's say count operations is equals to 99 operations, because I have added 99 directly to the 100 and make my array sum non-negative. So array sum will be then 0. But is this feasible? Which is not. It's not feasible to add 99 directly to the array element. I can do one more thing, which is I can divide this 99 into n number of parts. So my 99 will be divided into 3 parts, which is 33, 33 and 33. So now when I add these 33s to each of the element, now my sum is still non-negative, which is greater than 0, but my total number of operation is now 33, which is feasible and which is the rightmost answer for this problem. So how can I approach, how can make the formula for this? What I can do, I can take the sum of the array, and let's say the sum of the array is minus 99. So I need 99 more. So I will take the absolute value of this 99 and divide it by n and take the CL value of it. Or you can write it as absolute value of 99 plus n minus 1 divided by n. Absolute value of sum. So this will be my final answer, final formula, and I can write it in the code. Let's see. As you can see, I have taken test cases as input, then I have taken n input. I don't made an array because we don't require an array for this problem. Now I have taken a total sum as in 0 and I have run a for loop. Then I have taken the elements as input and added to the total sum. Now if total sum is already positive, then we need 0 number of operations, as we need absolute of total plus n minus 1 divided by n, which is the C value of total by n, right? So for this problem, this is the solution, right? Now moving towards the third problem. Now in this problem, you are given with, you starts with an integer x is equals to 0. For n turns, you do exactly one of the following. Either you add 1 to the x, or you add 3 to the x. For example, if n equals to 2, you can choose to add 1 on the first term and 3 on the second term. Thus, x final value is 4. Given an integer m, print whether it is possible that final value of x is m or not. Okay. For this problem, we are given with two integers and an m. Now we have to perform n operations in which we can add either 1 or 3. Now, if you see what is the minimum value that I can make from 1 and 3, the minimum value is 1 into n. That means I have taken all the 1 operations n times, right? This is the minimum value that I can make with n operations. For the maximum value, that will be 3 into n, which means I have taken all the operations with 3 n times. Okay, so it is clear that my m should be within this range, which is n and 3n. If it is outside this range, then the answer is always no, that we can make this possible. Now, what if it is in this range? Now, how will I check that I can make an m or not? First of all, if you look at the numbers which we are given with, that is 1 and 3, both of them are odd, which means if I add any of these, let's say x and y, if I add x or y, let's say 1 times, then answer will be odd. If takes 2 times, the answer will be even. If takes 3 times, the answer will be odd again. If takes 4 times, the answer will be even. Like this. As you can see, if the number parity is odd, the answer will be also odd. If the number parity is even, the answer will be even. So to make m, parity of m and n should be same, which means if m is odd, n is also odd. If m is even, n is also even. Right? Now, if is let's see if it's possible to make any element which is in the range of n to 3n. Let's take an example. Let's take an example. M equals to 5 and number of operations, let's say 3. Both of the parities are same, and I will take m equals to 5 again, and this time n equals to 2. Now for m equals to 5 and n is equals to 3, I can use 3 as the first operation, plus 1 as the second operation, plus 1 as the third operation. This gives us 5 in 3 attempts, right? Now, if m is equals to 5 and n equals to 2, as you can see, the parity of n is even and parity of m is odd. So any number of combination, that is 1 3 1 1 3 3 or 3 1, the answer will always be even. Whatever you do, you can't make m is odd. So the parity must be equal to m and n. The parity of m and n must be equal. So what we can say, that if we have any m which comes, let's write here. Let's say I have any m comes under the range of n comma 3n, and m modulus 2 is equals to n modulus 2, then it is possible to make n. Right. So let's look at the code for this problem. As you can see, in this problem, what I have done is I have taken n and m as input. Then I have checked that m comes inside the range of n and 3n. If it comes inside the range, then I have checked the parity of m and n are equal or not. If they are equal, if all these three conditions satisfies, then answer is yes, and the answer is no. Okay, so solvent tip 3. Good. Now let's move forward for the third problem. In this problem, oh sorry, it's a fourth problem. In this problem, we are given with chef has a strictly increasing sequence A of length n that he wants to convert into arithmetic progression. In one operation, chef can choose some integer and then insert it anywhere into the array. Find the minimum number of operations required for chef to achieve his goal. It can be proven that it is possible to under the constraint of this problem. Okay, so in this problem, it's quite good problem for division 2. In this problem, we are given with chef has an array A1, A2, A3, A4 up to AN, and each element is in the strictly increasing order, right? Strictly increasing order. Now, what we can say is in we have to make this array an AP. And what is the condition of an AP? Is that if three numbers are in AP, A, B, C, then B minus A must be equals to C minus B, which means the difference of two consecutive elements must be same. So let's say an array is like this: A1, A2, A3, and A4, and the difference is D1, D2, and D3. Now all these three differences must be same for the AP. Let's take an example. 1, 42, 43, and 100. Okay, so we are given with 1, 42, 43, and 100. Alright, in this, as you can see, the difference 1 is 41, the difference 2 is 1, and difference 3 is 57. Right, now I have to make all these differences same, or I can add some elements to make these differences same. How can I do this? Now if you look in this 41 element, difference 41, I need to divide this in such a way that all the elements, when I add them, like let's take 1 and 42 as two numbers, and I will add some elements here, right? Then the difference of all these elements must be same, right? And that should be same for 1 also, and that should be same for 57 also. Why? As we cannot change the elements itself, as we cannot change the element itself. So to make an AP, the difference should be common. How? So to make the difference common, what we can do? We can take the GCD of all the differences, right? Why? Why GCD? Now, as you can see, if all the differences D1, D2, D3 are derived from a common difference, let's say capital D, and D4, D5, D6 are derived from capital D2. This is D1 and this is D2. Now, both of them are different. D1 is not is equals to D2. This is something mathematical part, so keep up with me. If d1 is not equals to d2, and we want that d1, small d1 equals to small d2 is equals to small d3 equals to small d4 equals to small d5 and small d6, which means that d1 is broken into the elements such that d1 is also inside d2, which I can also say, state like this, that d1 is equals to some value of x into d1 and d2 is equals to some value of y into d4, right? As these three are same, so I can take all these three sum as d1 into x and d4 into x. Now, as you can see that d1 is a divisor of capital D1. Small d1 is the divisor of capital D1 and small d4 is the divisor of capital D2, right? Which means that if d1 is equals to d4, if d1 and d4 are equal, then d1 is GCD of d1 and d2, right? As you can see, if they are common divisor for both d1 and d2, then d1 is the GCD of d1 and d2. I can state that, right? So now when I've got that all the divisor must be the GCD of d1 and d2. Now how can I solve this problem? Now, fourth approach. Okay, fourth question. Which one? This AP1 or Kshitij को लेकर, right? So let's continue. So D1, as I proved that D1 is the GCD of capital D1 and capital D2, which means these capital D's are difference of the original elements. So I can state that if I take GCD of original differences, then the answer will be the difference of my AP. Correct? GCD is GCD of the original differences, which when I have taken the GCD of all the original differences, that answer that G comes, right? That G, this is the my difference of the AP that I will create. Now, how many elements that I need? If G is the original difference, sorry, if G is the difference of AP, and we know first element and last element, then total I can count total number of elements. How I can count the total number of elements will be equals to last minus first divided by difference plus 1. This gives us total number of elements in the array, in the AP. Now tot, which is the total difference, so total number of elements in the AP. Now how many elements I need? I already have n number of elements. Then I will just need tot minus n number of elements. Okay. Now moving toward the solution. As you can see, I have taken the input here. Then I have taken G, which is GCD for all the differences. I have iterated over the array. Then I have taken the difference of every element, every two consecutive element, and then taken the GCD with it. Then the GCD that comes is the original GCD for the AP. Now I have taken the total number of element, which is final, last minus first, divided by G plus 1, which is last minus first divided by difference plus 1. And how many elements I have? I have already have n number of elements. So how much elements I need? That is total minus n. Right? Is there any doubt for this problem? If not, we can move forward to the next problem. Why not minimum taken? Right. Okay. Look, let's take an example. Let my array be 20, 30, and 20, 30, and 42. Right. In this, my array is not in AP because, as you can see, the difference is 10 here and difference is 12 here. Yeah, I am explaining my GCD. As you can see, this 10 and this 12 are not equal, so the array is not AP. Now, if I have to make this AP, I cannot take 10 as the original difference for the AP. As you can see, if I take this 10, the answer will be like this, or I can say 42. This is in AP, this is in AP, but again, this is not in AP. So I have to divide 10 in such a way. Let's write 10 as some x into y, or this will be typical. I can break down x into some parts. Right? I can also break down 12 into some parts. Right? Now, after breaking down, I have to check that the parts must be equal to each other, and also the part of 12 is equal to the part of 10. If you take 10 is equal to 2 plus 2 plus 2 plus 2, and 12 is 2 plus 2 plus 2 plus 2 plus 2, right? So as you can see, the parts 2 and the parts for 10 and parts for 12 are equal, which is 2, right? So I can write my AP as 20, 22, 24, 26, 28, 30. As you can see, this is my original elements. Then I have taken 32, 34, 36, 38, 40, 42. Right? These are my original elements, and the number of elements which I add are these. Now, as you can see, the all the elements are in AP. Right? I have broken this difference 10 and this difference 12 in such a way that all the elements have the same difference. If all the elements have the same difference, it means that 10 has some factor which is equals to 12. Right? 10 has some factor which is equals to 12. So what is that factor? It is the GCD of 10 and 12. which is 2. That's why I was able to divide the element into 5 parts for 10 and 6 parts for 12. Now, why GCD only? Why can't I take 1 as one is the element that can make any number of any array into an AP? If you see like 1, 3, 5 or 6, now I can take 1 as 1, 3, 5 or so let's say 8. Still 9, right? Sorry, 1, 3, 5 and 9. I can take my common difference is 1, then 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be my AP. But in this, the number of elements that I have added has been increased. Like these are my original elements. And the number of elements I have added 2, 4, 6, 7, and 8, which is 5. So the answer for this is 5, but it's not optimal. What is an optimal answer is 1, 3, 5, 9. I can break it into 1, 3, 5, 7, and 9. For this, I have added only one single element, which is 7. So the answer is 1. That's why I have taken the GCD. GCD is the greatest common divisor, which means the greatest factor of 10 and 12. That's why the difference that is coming is always the greatest among all the differences which I have taken till now. Not all transactions. Yes, okay. So moving towards the next problem, max adds. Okay, for this problem, you are given with two integer n and m and two arrays a and b. Define fx as the following. Start with y is equals to x, and for each I 1, 2, 3, 4 dot 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 n in this order, update y is equals to max of y comma bi comma a y plus bi comma ai. Fx is the final value of y. Find summation of I equals to m fi, that is f1 plus f2 up to fn. Okay, this problem is pure mathematics, so let's dive into it. What we are given with, we are given with uh, an array a and an array p, p1, p2 to bn. Now we starts with value y is equals to x. For an fx, we start with y equals to x. Then in one operation we do y is equals to max of y plus bi comma ai, and then another operation we will again do y is equals to max of y plus bi comma ai. Now these operations follows in the order of I, which is 1, 2, 3 up to n, right? Now I will dive into the formulation part. So how the formula is derived for this problem and how you should approach for this. Okay, so I don't know any x. Let's start with fx, and x can be any value from 1 to m, as we are asked to find f1 plus f2 plus f3 up to fm. So I have taken any random integer x, any journal random integer x for fn from 1 to m, obviously. So I can to formulate something to approach towards the answer. How I can formulate it? Let's take the starting point. My start is y as x. Okay. Now in first iteration, this is my first iteration. my y will be is equals to maximum of x plus b1, I'm sorry, x plus b1 comma a1, correct? As my formula was y is equals to max of y plus bi comma ai. So currently y is x and my iteration is first, so x plus b1 comma a. Now second iteration, my y is equals to max of, now I will substitute this y here, so which will be equals to, let's say, max of x plus b1 plus b2, which is the next iteration, b comma a1 plus b2 comma a2. How I have substituted it, I can write it here. Minimum is not always I did two wrong for GCD. Just I thought greedily take minimum as a solution. No, minimum is not the solution. For that you have to take the GCD of the elements. That's when you can divide the original differences into sub differences such that all these sub differences are equal, and then you can take what is the number of sub differences, which is the GCD of the all the differences, original differences. That's why I've taken the GCD. Now let's put how let's see how I put this. So as you can see, I can take this as max of x plus b1 comma a1, which is my previous y, plus b2, which is the new iteration b, and a2. So this is the formula for the next iteration. I have opened this curly braces, then b2 will be added to a1 and b2 will be added to x plus b1. That's how I can write x plus b1 plus b2 and a1 plus b2 and a2, x plus b1 plus b2 and a1 plus b2 and a2, right? So for the third iteration, the same thing will happen. Max of x plus b1 plus b2 plus b3 comma a1 plus a2 plus a3, sorry, not a1 plus a2 plus a3, a1 plus b2 plus b3 plus b2 plus b3 comma a2 plus b3 comma a3. Now can you generalize this formula for the nth iteration? I can write it as y is equals to max of x plus, this is sum of values of b up to n comma a1 plus sum of values of b up to n but not b1, a1 plus, right? Same goes for a2. I can write it as sum of a2 plus sum of values of b up to n but not b1 and b2, right? I represent sum of values as prefix sum of b, prefix b. So I can write the formula as y is equals to max of x plus prefix of b up to n comma a plus prefix, let's write it as pb. Now pn and not b1, so I can just subtract p1 for a1 into for a2 as pn minus p2 and so on up to an as pn minus pn. Correct. So write it plainly as y is equals to max of x plus pn comma a1 plus pn minus p1 plus a2 plus pn minus p2 and goes up to an as pn minus pn. Now as you can see, the pn is common in this whole. I can take that out as y is equals to pn plus max of x comma a1 minus p1 comma a2 minus p2 up to an minus pn. Correct. Any doubt until this thing? No. Okay, so okay, so for this, can I write it as some value, let's say some variable k as max of ai minus pi for I 1 say n? Can I directly write k as this, as k is a1 minus p1, a2 minus p2 up to an minus pn, and its function is max, so I can take at k is equals to max of ai minus pi, where I is 1 to n, right? So my new formula will be y is equals to pn plus max of x comma k, right? Now this, what is this y? This y will be the fx, right? For general fx, this will be my formula, where k is max of I is equals to 1 to n ai minus pi, right? Now how will I find summation of I is equals to 1 to m fi, which is f1 plus f2 up to fm? Let's put this formula in the summation. Summation I is equals to 1 to m pn plus max of x comma k. Now this pn is a constant term, right? The sum of the whole array b, which is pn, so it's a constant value I can take out from summation as m cross pn plus summation of I is equals to 1 to m max of x comma k, right? This is my answer, right? Right here. Now how will I find I is equals to 1 to m summation max x comma k, right? So there are three cases for this. If my k is greater than equals to m, then the sum will be, this summation will be m into k, as all the k, sorry, all the value of x, all values of x will be less than k. So my sum will becomes out into m into k. If my k is less than equals to 1, which means 0 or 1, then my sum will be just 1 plus 2 plus 3 up to m, right? If k is 0 or 1, then sum will be the maximum value of x, which is 1 to m, correct? So this can be written as m into m plus 1 by 2. Now if k is in the range of 1 to m, sorry, not is equals to, k is in the range of 1 to m, then what will the formula? Then formula will turns out to be, my, let's take s1 as summation of all the elements up to x, and s2 as summation of all the elements up to m, correct? So then summation will be k squared plus s2 minus s1, right? If this is clear, let me know please. Okay, so let's move toward the solution for this problem. So as you can see, I have taken n and m as input. I have taken the array a and b as input here. This is my current value, and this is my x, which is k, obviously. And for this current value, I have taken the sum up to bn, which is the total sum of the array. Then for each value of ai minus current, I have, if x is if the value is greater than x, then x will be equals to value. Where my k is equals to value, consider this as k, right? Now what is the summation part? Coming to the summation part, the summation part will be, if my k is greater than m, then sum will be m into k. If k is smaller than equals to 1, then the summation will be just summation of x, which is 1 to m all the elements, so m into m plus 1 by 2. Else the summation part will be the two values which I have set to you, how that k squared is s2 minus s1 is general formula. Yes, it's not any general formula. For the third part, you can say that the k is in between the two elements, right? 1 and m, and I am taking the sum from I is equals to 1 to m of maximum of x comma k, right? This x is x will remain same, for like for fx when when fx is equals to f1, then x will be 1. For f2 the x will be 2. For f3 the x will be 3, and we are going up to fm. So the x will remain as 1 plus 2 plus 3 up to m. Correct. So x, for x to be greater than equals to k, or sorry, for x to, when taking maximum of x with k, we can state that if x should be the answer, it should exceed the k. So how many times it will occur? For x is equals to 1 to x is equals to k, it will occur k times. Correct. And for k plus 1 up till m, for k plus 1 okay. For k plus 1 up till m, what we can say that now if x lies in this range, then we need only the sum of k plus 1 up to m elements, which is easy that we can count. Sorry, k plus 1 up to m elements where k is the exceeding value of x. So we can just count the value of 1 plus 2 plus 3 up to m, and we can count the values of 1 plus 2 plus 3 up to x, which is the lower boundary, and m is the upper boundary. Then we can subtract these m minus x. So this will come out to be the summation of m, which is s1 minus s2, and this occurs when k is smaller than, when x is smaller than k. They, this occurs k times. So I can just add k into k. If still not understood, let me make it more clear like this. Maximum of x comma k. Now consider x in these two ranges. Correct. Now when x is less than k, how many times the maximum of when x and k will occur, how many times x will come? Zero number of times. Every times k will appear as the answer. Correct. So my answer will be k plus k plus k up to how many times? K times, because the upper limit is k. So when I take max of 1 comma k, max of 2 comma k, up to max of k comma k, the answer will always be k. And so after that, when you add this is just k into k, or k square. Okay, got it. Why need the other two cases? The other two cases are just for the condition, right? If k is greater than m, then every time k will occur, x cannot occur, because x can go up to x can go up to m, and when k is greater than m, then when you take max, every time the max will give our output as k. So max runs m number of times, and every time k comes, so summation will be m into k. If k is less than equals to 1, each and every time x will come out as the answer from max. And how many, what is the x? It will be 1 plus 2 plus 3 up to m, because it runs n number of times. So m into m plus 1 by 2. Now for this, you can see that when x is less, when x is between 1 to k, the answer will always be k. As we can see, the maximum of 1 comma k is k, 2 comma k is k, and 3 comma 3 is up to k comma k is k. So k plus k plus k plus k, the answer will be k into k, which is k square. Now if x is between k plus 1 and n, I can take that the x will always come as the answer. Then how can I find the sum from 1 to m? Let's say k is 5 and m is 8. K plus 1 is 5 and m is 8. How can I find the sum of 5, 6, 7 and 8? Because x increases like this, so I can just take 1 plus 2 plus 3 up to 8 and 1 plus 2 plus 3 up to 5 and subtract both of these. Then I can add k square plus this sum. This term gives us answer. Last trick is felt hardest to derive. Yeah, it can, but when you look closely and you observe that there are only three conditions. Either k can exceed such a value that x cannot enter in the scenario, because x can go up to m. So if k exceed m, then always answer will be k, 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 k for every max. If k is less than equals to 1, then answer can never be k. Then answer will be always be x for m number of times, and x increases like 1, 1, 2, 3, 4, 5. Then we will just add all these numbers, which is the sum of the natural numbers. And for the third case, I've just explained. Right? Is there any other doubt? As you can see, for this particular problem, I've taken that summation of Pn here, and I've taken the summation of Pn into m here and sum here. For x, k is greater than equals to m, the answer is m into k. If k is less than equals to 1, the answer will be just summation of all the values of x, which is m into m plus 1 by 2. If else the k is between 1 and m, then answer will be k into k for the value of when k, or when x resides between 1 to k, and when x resides between k plus 1 and 2 is less than m, then answer will be s2 minus s1. Then we can just do m into current, which is the Pn, plus sum, which is the summation part. That's how I would derive the whole formula. So moving towards the next problem. For this problem, I don't know why this is the fifth problem of this. This is more like, this is easier than the previous one. As you can see, in this problem, we are given with an array A of n non-negative integers, and in one move, you can do the following. Choose any index L and R such that 1 to L to R to A mod is the size of the array. Now let X be the max of that segment and insert X into the array. Okay, we choose the X as the max of the whole segment and we inserted X into the array in any position. Given an integer k, find the minimum number of moves needed to insert k into the array. Note that you don't need to you need to do this even if k is already present in the array. Okay, this is probably much easier if you get one intuition that it is possible that first, let's see what we are given with. We are given with an array up to an, and we choose any segment L to R. So AL up to AR, and we find MEX of this, which comes out to be X, then we can insert X at any position in this array, right? And we need to find minimum number of operations to such that we insert k in the array, correct? And there is possibility, is there not? There is tree counting problem at the end. Okay, so there so you can observe one thing, that k can be present in an array. Let's take an example for k is equals to 5, and array looks like 0 1 4 5 3 2 1 0 5 6 10 15 5, right? So this is my array. So what I can think as my solution is, there are 5 present in some locations. So choosing a segment which contains k can never give me a right answer. If you choose this segment, you see that all the values are present in this particular segment from 0 to 5. Then max will be 6. Or you can easily state that if k is present in array, k is present in the array, then I the max can never come out to be a, right? If k is already present in an array, the max can never be k, correct? So to find max, to find an element, or to find a segment when taken max, that gives us k, will be the segments which does not contain k in them. So the segments will be from 0 to 4, from 3 to 0, from 6 to 50. Or I can represent my new array as this. I will just skip. I will skip uh, all the positions where the k is present, and all take all the segments in between those k. Now what I have to do, I will just take max of these elements and find out how many elements I need to insert it there. Okay. So we will just find out how many elements we need to insert in here. Like if this is 1, 2, and 4, then the max will be 1, correct? And the number of elements, sorry, the elements which are present is 0, 2, and 4. All of them are less than 5. So I can count all these elements as 3. So how many elements I need, which is 1 and 3, to make max is equals to 5. So the answer will be just k minus size of this set. So I can take the k minus size of this set. In the set only contains element less than k. Why? For max is equals to For making max 5, do we really need any element which is greater than k or which is greater than 5? Do 6 help us in making max is equals to 5? No. Do 7 help us? No. Do 100 help us? No. What are the elements which help us? Which is that is 1. 1 will help us to make the max is equals to 5. It is not present in that segment. So what I do, I will iterate over the array and include my elements into my set which are less than k, and then takes just k minus set size of this set every time I encounter a k. Correct. Every time I encounter k, then for this particular example, let's take this particular example. Right. For this particular example, as you can see, what are the elements that are present currently in my set? It will be 0, 1, and 4, as all of them are less than 5, as my case 5. So the set size is 3. 2. So I can take two more element 2 and 3 and insert in these positions. Then this segment will give us max as 5, which will be my answer. So the answer for that, how I calculated 2, which is just k minus 3 or 5 minus 3, whatever. We can write it as k minus set size. And in this segment 3, 2, 1, 0, I have 0, 1, 2, 3, and I need 4, when I insert here, which we will get max as 5. So how I calculate that answer is 1. It is just k minus set size 5 minus 4. So we need only one element to make max is equal to 5. For this particular, there is no element which is smaller than 5. So how many element I need to insert in there? 0, 1, 2, 3, and 4. These are 5 elements, which is just k minus set size. And set size is 0, so k minus 5 minus 0 is 5. That's how I can calculate this particular answer for the problem. This problem is easier than previous. Yeah, this is easier than previous. Okay. So when you look at the code, here I have taken the input of the array and k. My answer is equals to k, which is the maximum number of operations which you can take. You can take all the element and put inside to some segment, and the answer will be max. The max will be k. Then I have taken an unordered set because I don't need the ordering and it is faster in these scenarios. Then I have taken, I have iterated over the array. When at every particular point when I encounter k, I just take my answer as the minimum of answer comma k minus set size. And am I clear out my set? Correct. And else I just add the element in my set if it is less than k. I've done this again because at some particular point it might be possible last element is not 5, so we have to add again. So I've taken this and my answer will be answer plus 1. This plus 1 is just addition operation, last addition operation, because it asks us to insert k also, which means it asks us to insert maximum also, so that's why I have it plus 1. Right. So that's for this code. This is easier problem, right? This is a problem. Any doubt up till this? Okay, so let's move toward the last problem, which is tree count. Okay, in this problem, give me a second. It's not live, it's live. Okay, okay. So in this problem, you are given a rooted tree of n vertices numbered from 1 to n. The tree is rooted at vertex 1 for a subset S defined Fs as the unique set satisfying the following conditions. S is a subset of Fs for all x comma y. These are just nodes which belongs to Fs. It is also true that LCA of x comma y belongs to Fs, which means if two nodes are present in an Fs, then the LCA of those nodes must also be present in an Fs. Among all the sets satisfying the above two conditions, Fs is the smallest as possible. This is again the size. The size of the set should be the smallest as possible. For each k equals to 1 to n, find the number of subsets S such that Fs is equals to k. Okay, the set size is equals to k because the answer can be large print model of this. And there he explained what is an LCA. LCA is just a lowest common ancestor for the two nodes. And in this problem, you are given with n is 2500. So you can run an n squared approach. Have you come up with any solution for this problem? Were you able to? Hmm. So this is a quite interesting problem. What technique I have used is DP on trees with inclusion exclusion principle. So what Fs is in this particular problem? Fs is a set of all nodes such that every two node have a ancestor inside Fs. Sorry, lowest common ancestor. Right. So you can say one thing also if you can observe, like if this is my tree, right? If this is a tree, then if 4 and 5 is present in my Fs, then 3 must also be present, right? If 4 and 3 is present, then obviously, well, which means 3, 4, 5 is a valid Fs, correct? And if it is a valid Fs, as you can see, that this makes a subtree, correct? And also we are asked Fs size should be minimum. I can reframe it as the minimum connection path of all the nodes of tree, right? Correct. Great. Okay. Now, if you pick any two nodes, if any two nodes are picked, the LCM will be the highest point of that subtree, of the subtree, or I can say the size of the FS, right? Right. If there is any tree, if I take these two elements or these two nodes, then the LC of these two nodes are this, which is root, and the whole subtree will must be inside FS or not? No. Why? Because when you take, let's say this is 5, this is 6, and this is 1, as it is rooted at 1. So if I insert 5 and 6, then I only need to insert 1 in the subset. I don't need these elements. Because when you take LC of any two elements here, 5 1, LC of 6 1, or LC of 5 6, the answer is already present in this. Correct? Okay. So how will I connect this all these elements? I will use a post order DFS, and when we are at a node, let's say U, I look down at the subtree of U. I look down at subtree of U. Then there are three situations that matters. Let's say there are three states that I need to consider. Okay. So first state is we decide to pick U as the part of the subset S. Correct. So if U is the part of the subset S, then we can also conclude that U is the part of final subset FS. Correct. And it is it connects everything below it. Everything below it. My second state states that when U is not chosen, only one of the U's children has an active node. I can conclude this. Only child has active node. Correct. So I can also say U is not inside FS. My third state will be when U is not present, but two or more of its children are present in fs, sorry, in set s. If two or more children of you are present in s, then we have to take u inside fs. Let me explain with an example. This might be typical for you. Wait. So if there is a tree like this, okay, so this is a tree, and let's say this is you. Okay. If u is present in the set s, s, then it must be present in fs also, because s is subset of fs. So first condition is true and logical. If u is present in s, then u is also present in fs, because s is the subset of fs. Correct. Second condition says if u is not present, but why I'm writing. Second condition state if u is not present in the fs or s, u is not a subset of s, but a child of u is in s. But I have said only one child of u is in s. You can take any child this. If this is present in a set, then there is no need for u to be present, because if any other child was present with you, like if this child is also present in the set s, then you have to be present, because lc of these two childs is you only. But when I take only single child, the lc is not you, then the lc is someone else. For example, if I've taken this element with this element, then lc will be this particular root. So that's why root should be present, not you. So this was my second condition. My third condition is u is not present in the s, but two or more child of u is in s. So you have to be in the fs, because if u is not there are, let's say, three or four childs, and two of the child of u are present in s, then lc of these two childs are u, this particular node. So you have to be present in fs also. Is that clear? All three states are clear or not? Okay. So this might be clear. Now about the for all these three states, I can choose three DPs, in which first DP will describe first state, second DP will describe second state, third DP will describe third state. About the transition, come to the transition. But transition function will we can we are essentially multiplying polynomials or doing knapsack like merging. So I can write as knapsack like merging for U and its children, correct? So now I can say, let's take scenario 1. U is present in first DP, which is DP1. So it doesn't, so I can say it doesn't matter if child is present or not. So my new size will be old size plus child size or subset size, subtree size, sorry, subtree size. Correct. So this is my scenario 1. Now my scenario 2, if U is present in DP2 and child is also single child, is the single child is also present. So when U is present in DP2 and single child is also present, we can say we have one active branch in this particular scenario. And what does this means? That uh, we have a active branch from previous child, which is this and U. Now we need to find another active child. So for this, we need to find another active child. Correct. So in this scenario, we just add U to our count. Right. The third scenario, when U is not present in DP3, but two or more child is there. Right. So if U is not present and two or more child is there, then U now has only one active branch. And my state will be same as state 2 of scenario 2. We will keep this same. Correct. So let's look toward the solution for this problem. Okay. As you can see, here I have taken T and N as input. I have made an adjacency list and pushed the two edges U and B. As it is an undirected tree, so we have pushed from both sides. Now I have written a DFS. What this DFS returns? Let's see. That in this I have made three DPs, which are the three states as I've described, in which when U is present, so I have to take the whole subtree of the U. If U is not U is present and its one child is present, So you need not to be present in fs, and we will just add the branch u in our dp2. And for dp3, it is that two or more children of u are present in dp, and have to take u in our fs. So what I have done, I have iterated over the adjacency list of u. If parent and child are equal, then we can just continue. Else, I have taken I have called the dfs again. Then c1 and c2 are the first and second child, which comes out from this dfs as pair of vectorins, and c1 is just vector of it, which is means the child subtree, and c2 is the second child subtree. I have taken the maximum of those two trees and the sum vector. What does this sum vector do? It takes the subtree size sum. So I've iterated over the first child and taken the sum of all the elements or all the children's or grandchildren of u. Then I've iterated over c2 and then take the sum of grandchildren of 2 c2. Then for the first part, as I've said, I will add my subtree size to my dp1 as my scenario 1. Now these are just NDP states, so that I can reduce the space for the competitive programming stuff. You can also do n into l, length into size of the n, length into n dp, but it might exceed time limit. So now what we have done, we have iterated over dp, update our new dp with the previous dp states, and I have iterated over the same dp again. If DPI is not present, which means the subtree size for that particular element is not there, it is a leaf, then I just continue. Else, I just iterate over the sum and add my sum or the subtree size to my NDP as NDPI plus j is equals to NDPI plus j equals to NDPI plus j plus DPI into subtree sum j modulus mod. Next, for the dp3, I've iterated over dp3, then again add the subtree size to the ndp, update the ndp every single time. Then I've iterated over the size of this subtree. If it is not present, it is a leaf, so I can just continue. Then I have iterated over the third scenario, that if third scenario is true, like if there are two or more children that are present in that particular state or in that particular dp, what I have done, I have again added as ndp3 I plus j is equals to ndp3 I plus j plus dp3 I into sum j modulus mod, correct. And for the dp2, I've also said that it will be same for the both of the two scenarios when u is not present and single child is present, and when u is not present and both of the child are present. So you have to be present in that, in the same scenario, they will be same. So I've iterated over dp2, and for dp2 just and dp3, this is the same transition function as this, as you can see. Now, when you have iterated over all these scenarios, you can just update your new DPs with the DP2 and the subtree size, and update the DPs here. So this will return new DP states for each and every child that is present. Now my final size will be the maximum size of DP1 or DP3 plus 1. One is just for current Q which is present, and the final type 2 is what I've done is there scenario 2. For the scenario 2, the final size of final array will look like this when you iterate over the dp1 then the final type will be just for the dp1, or I can say the final will be same as the u when u is present in the array. And then I have iterated over the third dp, and I plus 1 is less than final size. Final size type will be equal I plus 1 equals to addition of dp3, which is the third type. Then I can return dp2 and the final type 2, right, for this. And after that we will get dp2 and final dp2 here. Then I can iterate over all the nodes. Then my answer is equals to 0 if my nodes are less than the size of dp2. Then I can add it to my answer. Or when the same thing, when it is size is smaller than the final dp2, then I can add my answer to it. Then I can just output my answer. So that's how we can print all the sizes of fs. Yeah, I think, is this clear? Is there any other doubt regarding this particular problem? If not, we can conclude this session. Thank you so much for joining, and I hope you understood all these problems which we have discussed. And if you have any other doubt, you can ask right now, or you can message me also. Okay. Okay, thank you guys. You can just stop.